Okay, disability, innovation, and spin-offs is the title of my talk. Spin-offs being the more interesting part of the talk. Notice from this slide that I come from a family of bad spellers. We spell our name Hayes, H-E-Y-E-S, not the normal way. And you might also notice I've been killing myself by degrees. You probably know that people with a disability have benefited enormously from modern technology. Perhaps what you don't know is that frequently things go the other way. It's the inventions for the disabled that sometimes find a use elsewhere. For instance, did you know that Alexander Graham Bell had a deaf wife and a deaf mother, and he developed a means of communicating with them, and it turned into the telephone? Did you also know that Peregrino Turin invented the first typewriter because he had a blind girlfriend and he wanted to get letters from her and she could use the typewriter? Those younger members of the audience might have to Google typewriter. It's a sort of keyboard thing, you know. Likewise, you might have to Google long playing records because they were first introduced for talking books for the blind. And you could get a book on about 10 LPs. Of course, it's all MP3 these days. It's all very different. But I can remember long play. I'm sure we all can. 33 and a third revs per minute. Okay. There's an old adage that necessity is the mother of invention. And I had to look up. I wonder where that came. Was it Shakespeare? No, it wasn't Shakespeare. A bit older than that. Plato apparently came up with that one. Now, I spent my life coping with low vision. I'm basically as blind as a welder's dog. I don't see at all in my left eye, and my right eye is just held together with bits of string and sealing wax. But, you know, I try to cope. So my life is spent coping with this. And I think that it's actually led me to come up with ideas and innovations that have helped me, helped others, and there's spin-offs that's helped everybody. And I'm willing to bet that some of them help you as well. So my first encounter with science was a great disappointment. I was about 8 or 9, and it was deemed that I should have spectacles. I consoled myself, of course, by thinking, well, I could make fire. I could focus the sun rays and make fire. But of course, I was short-sighted, and I found that there were things called negative lenses, and negative lenses don't focus the sun's rays into a spot, they spread them out. And then later on in life, I read a book and saw a film called Lord of the Flies. Well, it was about boys marooned on a desert island, and they fought each other for the ownership of Piggy's specs. Piggy was a rather rotund, myopic guy, but Piggy's specs made fire. Well, of course, it was nonsense. They didn't make fire. I suppose that's what's called artistic license. William Golding, who wrote the book, got the Nobel Prize for Literature. You have to worry about that. Anyway, I went to a school in Bolton, Canon Slade's Grammar School, Church of England School, my goodness. And I had my first physics lesson when I was about 13, and I hadn't come from an academic family. I really didn't know what physics was, but I wasn't stupid. I knew what physical education was. So I said to one of my classmates, do you think we should take gym shoes along to the physics lesson? Anyway, when the door opened, it was like stepping into an Aladdin's cave. There were magnets, there were lenses, there were coils of wire, there were copper calorimeters and all sorts of things. From that moment on, I knew this is what I wanted to do. But of course, it's a difficult subject and you have to be bright, and I wasn't. And I wanted to go to university, but I couldn't, because in my day, you needed a language. And, you know, I can't even spell my own surname. And when I learned that French, the word yes was spelled O-U-I, I thought, well, that's it, you know. I failed French 5 times. I did not get into university. I went to a College of Advanced Technology at Salford. But while I was there, it became a university. It was a 4-year sandwich course, alternate 6 months in industry. And lo and behold, after struggling like hell for the first 2 years, the penny dropped and I suddenly began to understand my subject. And while I was there, Salford became a university, and I ended up with a first class honours degree in physics, for goodness sakes. And on the basis of that, I went, oh, that's Salford. That's a picture painted by Lowry. And given the date of that picture, I'm probably in there somewhere as a little boy. I'm not quite sure where I am, but that is Salford, very working class. On the basis of my career at Salford, I went to the Cavendish Laboratory at Cambridge. Well, that was an extraordinary transition. And that's the picture of the old Cavendish in Free School Lane. It's now moved to a much less exciting building, but a modern building. And of course, the Cavendish, as it's known, was a name dropper's paradise. I met all sorts of eminent people like Mike Murray, for instance. In fact, Mike and I not only worked in the same lab, we actually lived together for a while. We had a house with 6 physicists in it, a bit like Big Bang Theory. I used to chain my bicycle up, and 2 or 3 times a week, I'd see an old boy, he'd chain his bicycle up next to mine, and we'd nod politely to each other. Never heard him speak. One day, somebody said to me, "You know what that is, don't you?" I said, "No, not a clue. It's Paul Dirac." Anyway, and I got to know this fellow and his fiancée. This fellow later on became this fellow, and I guess you all know who Stephen Hawking is. And of course, you've all seen my T-shirt, and you've all recognized the fact that this is the temperature of a black hole, Stephen's formula, and it's the only formula that I know that has constants from both classical physics. It's got Boltzmann's constant, it's got the Newton's gravitational constant, and constants from quantum physics. It's got Planck's constant in there. It's the only formula I know, other than the entropy formula, again, Stephen Hawking's, that has constants from the two areas of physics. So it's really a rather special T-shirt. And this formula is on his plaque in Westminster Abbey, on the floor of Westminster Abbey. Now, Stephen, of course, was a theoretician, and he worked on black holes. I was an experimentalist. I worked on brittle fracture and things like that. So we never worked together, but we consumed a fair bit of the local beer together. I worked on stress waves in solids, crack propagation, and the cleavage of crystals and ultrasonic testing. But when Stephen got motor neuron disease, I went blind. I had bilateral detachments. I used to be extremely short-sighted, very, very thick specs, which did wonders for my IQ, but nothing for my sex appeal. And I used to call them my flashes specs. Imagine waiting outside the school gate for the kids in a dirty raincoat wearing specs like that. You know, my flashes specs. I worried about my eyesight getting more and more short-sighted. I mean, I ended up sort of 15 diopters in one eye and 13 diopters in the other eye, and it got even worse than that. And my doctor sent me along to Addenbrooke's Hospital, to the eye ward, to get checked out because I was concerned about this. And the very first thing they got me to do was to pee into a bottle. I said, no, it's the eyes, it's the eyes. Anyway, they were looking for diabetes and things like that. And they decided I had glaucoma, which is high pressure in the eye, which leads to blindness. They said, your short-sightedness is a problem, but you can treat it with lenses or contact lenses. Glaucoma is a serious problem. It's going to make you go blind. We've got to lower the pressure, and they treated me with a eye drop called pilocarpine. Well, years later, hang on. Towards the end of my PhD research, I actually had bilateral detached retinas. Both retinas came off, both eyes. I was blind, and I had embarked on a whole series of operations. I had 7 unsuccessful operations in Cambridge, and then eventually I was transferred to Moorfields in London. And the reason I got this wonderful opportunity to go to Moorfields to see the country's best person was due to the I had a successful operation in 1966, which restored the sight in one eye. It's not very good, but I drove a car until I was 60. On the left there, you see my supervisor, a man from Tasmania, Philip Bowden, who happened to be the uncle of Tim Bowden, who did the Backcheck program, and Tim died very recently. But he was my supervisor. He was a big friend of C.P. Snow, Lord Snow, the novelist, the two culture span. And they were obviously talking about me one night. A poor chap, he's got all these operations. He's not doing very well. And Snow, in his characteristic, said he should see country's top man, Lorimer Feiston, at Moorfields. He sorted out the Duke of Windsor. And my prof said, he can't see the country's top man. He's just a research student. And Lord Snow said, I'll fix that. And he rang him up and he spun him some yarn about this whiz kid at the Cavendish who'd gone blind, and you'll have a look at him, won't you? And the rest is history. I mean, I knew nothing of that. Strings were pulled on my behalf. Years later, I learned, when working in America at an eye hospital, I learned that pilocarpine was not the thing to give to high myopes. It produces spasms on the retina. And they said, you should sue them. They cause your detachment. Well, I said, we're British, we don't do that sort of thing. But I did learn a new word. And this is an interesting word. The word is iatrogenic. An iatrogenic disease or complaint is one caused by the medical profession. Iatrogenic, a fascinating word. I spent most of 1966 blind. I didn't see England win the World Cup. They never won it since. I wanted to devote what energy I had to, in some way, ameliorating or solving, not solving, but ameliorating the problems of blindness for others. Blindness is a dreadful thing, and I wanted to try and help others. I wanted to try, I was quite good at electronics. I thought, well, I can do something along those lines. But opportunities to do that sort of thing were few and far between. But I looked for an opening. And in 1970, I joined the Blind Mobility Research Unit, which was at Nottingham University. I'd spent a little time in industry working for Alcan, but I left Alcan and joined Nottingham University, but it was in the psychology department. I mean, I was a physicist going into psychology. It's a whole different world, a whole different language. I mean, I used to think that reinforcement was putting steel bars into concrete, but in fact, they used the word very differently. Now, they were, the question that I wanted to ask is, what is the information that the blind pedestrian needs? And can we give it to him? What is that information? I realized it was unlikely that I would produce an artificial seeing system, but could I perhaps provide the useful information? And the man who ran the unit said, yes, but you'll come up with the engineer's answer, and they always get it wrong. And a physicist, after all, is only a glorified engineer. He said, what I want you to do is to do long cane training under blindfold, and also work on a research project to do with the hard of hearing blind. Blindness is very much associated with elderly people. Elderly people often have hearing problems. If you can't hear very well, then and you can't see very well, then you're more than doubly handicapped. And the provision at that time for the Department of Health was a single chest-mounted hearing aid. Now, it was very easy to show with a series of experiments that blind people benefited enormously from stereophonic head-mounted, ear-level mounted hearing aids, because they need to be able to localize sound, they need to be able to orientate with respect to sound. Blind people walk an awful lot better along a busy road. You might think that they want quietness, but the sound of the traffic is a means of orientation. And so I was sent off to do long cane training under blindfold. And the long cane is, and hearing aids for deaf blind. That's the long cane in use. It comes up to about the sternum, and there's a technique of using it by swishing it from side to side, and it's a particularly good mobility device. Of course, you also are listening, using your ears to listen to ambient sounds, also the sounds of the cane tapping. And even today, with my eyesight, I often snap my fingers and get some echolocation, use echolocation. You learn these techniques. And Alfred Leonard, who was my boss, he was quite correct. I learned an awful lot doing this sort of training under blindfold. I wanted to work on, I basically provided technical services for the other people in the unit, the psychologists, for quite a while. And they were doing gait analysis, looking at the movement of blind pedestrians through the environment. And this was the 1970s. We were filming in the streets, in the real world. Big cameras, I mean, in those days, and even shopping trolleys with equipment and being trundled along. And we were using video cameras to record performances, and we were looking in terms of safety, efficiency, and stress. Blind mobility is stressful. A blind person gets to work, he's exhausted, you know. And we were developing measures so we could evaluate different training techniques and different devices, because there were some devices. We measured the heart rate of blind pedestrians. And of course, the heart rate is dependent not only on anxiety, but physical movement as well. Now, there was a little background. There were some devices. Most electronic devices, a few electronic travel aids had been invented. The majority used ultrasonics, high frequency sound. In other words, rather like the bat. The bat manages to steer himself around very successfully using ultrasonics. A man called Leslie Kay, an Englishman who went out to live in New Zealand, he was the professor of engineering at Christchurch in New Zealand, and he developed a thing called the sonic torch and also the sonic guide. Now, the sonic torch both used ultrasonics, and both fed information to the blind person's ears. Now, he tried to include a lot of information. It sent it out. The ultrasonic torch was a single beam handheld device, and as you approached an object, you heard a coming down in pitch, and the quality, the sort of timbre of that sound, gave you some information as to the texture of the surface. If it's a solid hard surface, you got a fairly single note. If it was a bush or a tree, you got a sort of a mixed sort of sound. So it gave you information about the object, and it gave you distance as you approached. Now, the sonic guide was binaural, and if the object was center, you got a equally loud in both ears. If it was on this side, it was loud in this ear, and you hear a little bit in that ear, but if it was on that side, of course, it was loud in this ear. The problem was with the sonic guide, two problems with these devices. One is the sound they made was rather like ambient sound. So it tended to actually camouflage the sounds that blind people wanted to listen to anyway. The device sort of rather interrupted that. It interfered with that. The other thing was the sonic guide was that if you walked through an open doorway, you got an object there which was loud in this ear and soft in this ear, and an object here which was loud in this ear and soft. And the two combined to give you a central, it was as if it was a central object. So to get through an open doorway, you had to virtually walk to what was almost like a central object. It was slightly ethereal. But, you know, under the stress of blind mobility, to try and decide whether it really was an object or really was a gap, looking for the ethereal nature of the image was a bit much, actually. And a lot of people had difficulty. I think we're getting a bit of feedback. Maybe I'm talking a bit loud. Most users had a lot of difficulty. Some were very good. And neither device, of course, picked up down curves. You had to be used in conjunction with a cane, because if you think of sending out a pulse of ultrasonics or anything like that, you don't get an echo from a down curve. You do from an up curve, but not from a down curve. So they had to be used in conjunction with a cane. So, of course, it made it very much more sense to have the head-mounted sonic guide than the handheld sonic torch. I wanted to work on tactile display, on displays and devices, but I wanted to try and limit the amount of information. And the reason why I did is an experiment that Alfred Leonard did. And we talked about the phantom assembly. That's a sonic torch, and that's a sonic guide. Now, Alfred Leonard argued that since it was not possible to give a real picture of the world, perhaps we should give limited amounts of information. And we both agreed on that. And he did a, a, a very simple experiment, and psychologists do some very odd things. He did an experiment at a shopping center with a radio link to a blind person. And he could give information, simple information to this blind person, and he could turn a fairly ordinary performance into a brilliantly smooth mobility performance by giving very simple information. He could either tell him where objects were, object to the left, to the right, or he could tell him where the gaps were. Didn't have to specify what the objects were, just very simple information. And we both thought that wouldn't it be wonderful if you could have a mobility device that would do that, just give the essentials, and give the essentials in a way that didn't interfere with your normal hearing. And I wanted to work on that. So this is the radio link experiment. I'm missing my cues a bit here. And the question was, could we design such a device? And the device would have to have some sort of intelligence built into it. You had to sort out what was relevant to the user. And then something happened. San Francisco. I was invited to go out to San Francisco to work for a while for a guy called Paul Baquirita, an unusual name, Spanish and Mexican name. Now, this is Paul. Paul was a medic. His father had died of a stroke. His father had had a stroke and had been severely impaired. He could neither speak nor walk. And Paul and his brother, another medic, subjected the father to a pretty rigorous training technique. And they taught him to walk again. They taught him to speak again. And he went back to work as a lecturer at university. And when his father died, he died while walking on a holiday in the Andes. And Paul did something that was pretty unusual. He attended his father's autopsy. Now, you don't normally do that. And Paul was particularly interested in looking at the parts of the brain that had died, in inverted commas. And of course, they had not recovered. What had happened is that other parts of the brain had taken over. This was the 1970s. It was almost universally believed that the brain developed until your early 20s, and then from then on it was downhill. Paul proposed that there was this thing called neural plasticity. The brain could actually change. It could learn new tricks. Different parts of the brain could take over parts of the brain that had been lost due to the stroke. And he extended this idea to think in terms of neuroplasticity and sensory plasticity. And he built a dentist chair. And this dentist chair had on the back of it an array of solenoids, vibrating pins. It was a 20 by 20 array, and people took their shirt off and sat in this chair, and they got and they saw a picture on their back. And you can see the camera, see a 1970s type camera. If the camera was absolutely still, this picture meant nothing at all. But the moment you started to move the camera, this picture on the back became alive. You really began to feel something. And I've got one or two shots here. You can see what it is, the picture at the top and the representation. Resolution, of course, is pretty poor, but nevertheless, you could recognize certain little watering can, you could recognize simple objects, and even the odd face. Now, it was very like vision. You were seeing through the skin of your back. Very strange. It needed motion, but so does the eye. If you fix the eye and stop it moving, then your vision fades. The eye needs these little saccades, and so did the camera and the back system need the saccades. You had parallax. In other words, I only have one eye. If I want to judge distances, I can move from side to side. People at the front row move more rapidly across the visual field than people at the back. So you can judge distance by parallax. This had the same phenomenon. It had looming. They played a trick on you. You sat there looking at something, and they would just reach across and give the lens a twist, and the image would suddenly get big, and you jump backwards. Well, at this stage, you were relating it to being out there, you know. So it had many of the features of vision. In fact, I learned from Paul Bacchiarita, and I still believe it, that you don't see with your eyes, you see with your brain. The eyes are simply transducers. And Paul argues and argued very successful that if you, once the information has passed the eyes, it's just electrical and chemical signals. And if you can get those electrical and chemical signals into the central nervous system through another route, then why not? It would be equivalent. Anyway, they wanted to get the chair mobile. And that's why they invited me out and a colleague from Nottingham, because at that time we had the more expertise than anybody of blind people in the street situation. And they found that they could replace the vibrating solenoids with tiny electric shocks built into a vest. So I had a vest, and they moved it from the back to the stomach because it was a bigger traffic-free area. And they used constant current source and obviously got the conditions right, so it didn't actually give you a nasty electric shock, but it felt just like a little vibration. And people who trained, because a bit of training was needed, using the system on the back, did not need new training when it moved to the stomach. So, you know, you were training the central nervous system, you weren't training the skin of your back. And so moved the back to the stomach, and the problem was resolution, though. The problem all the time was resolution. You can actually poke somebody in the back anywhere and they'll feel it. But if you want to poke them at two places simultaneously, they will only recognize them as two places if they're fairly well apart. And this is known as the 2-point threshold. And the people in San Francisco argued, yes, we can measure 2-point threshold, and it looks as if we're exceeding it, but it's probably different for pictures. If you've got more than 2 points, pictures. And at this point, while I was there, we had a visit. We had a visit from Richard Gregory. Now, Richard Gregory had written a book called The Eye and the Brain, and it was the world's best-selling science book until Stephen Hawking came along and wrote The Brief History of Time. It really was a very popular book, The Eye and the Brain. And Richard was no slouch. This is a little aside, but it's worth telling. Richard did a calculation and basically suggested that we could knock out something like half the pins of this 20 by 20, 400 pins, reduce it to about 200 pins, and your performance would not start to deteriorate until you got less than that. In other words, we were already overdoing what the skin was capable of feeling. And it turned out he was right, but I don't think the San Francisco people like to hear that. Richard was a force to be recognized. He took the best picture of the moon before satellites were up there taking pictures. And he did it from his back garden in Bristol. And he did it by a very simple technique using a beam splitter. The beam splitter, the light comes in from the left, half the light is reflected upwards, the other half of the light goes straight through. Well, he had the camera at the end of one beam, and he had a photocell at the end of the other. And what he did, he arranged that the camera shutter was only open very briefly, but only at the peak of the light. And of course, atmospheric interference caused the light intensity to wobble. He was just opening his shutter at the very peak, so when the best light was coming through, and he got the best pictures of the moon than anybody had ever had until they sent up satellites, which is quite something from your back garden. Anyway, he came up with that. We got the chair mobile, but using electrical stimulus on the stomach, but there was an unforeseen problem. When you start to move around, that stomach cloth, the support of the electrical signal starts to move a little bit, and occasionally you got a bad connection. And although it was constant current source, current density suddenly shot up, and it was like having a pin stuck in you. And the very last thing that a blind person wants, who's under stress anyway, is to know that any moment now he might have a pin shoved in him, and it really didn't work out terribly well. But the concept was very interesting. Lots of people thought Paul was a bit of a charlatan. This idea of neuroplasticity was slow to take on. People didn't necessarily believe it. What happened was that the dentist chair was there, and there'd be a succession of elderly, rich, sighted San Franciscans would come along, take their shirts off, sit in the chair, experience this, because we could all experience it, and say, well, what's the problem? What do you need? Oh, well, of course, finances, money is a problem. Out would come the checkbooks. Now, not many people are doing research that can pull in funds quite that way. And of course, there was a lot of jealousy amongst Paul's friends. I came away not knowing, was he a charlatan or not? He certainly was into some very interesting stuff, and I wasn't quite sure. The chair was the fundraiser. And then years later, a year after Paul died, Norman Deutsch published a book which was sold very well in Australia, called The Brain That Changes Itself. And it's all about neuroplasticity. And the first 2 or 3 chapters are all about Paul Bach-y-Rita in his work. And he went on to work with a display on the tongue, an array of electric shocks given to the tongue, because the resolution there is very good. It's good on the fingertips, but they're used for other things, of course. And people with a tongue display throwing balls into hoops and playing cards and things like that, really getting a sense of vision through a different mode. Meanwhile, back in Nottingham, I got back to Nottingham. I was given the opportunity to work on electronic mobility devices. I was convinced that Alfred Leonard was right, and we were most likely to be successful if we had simple devices with a simple display that gave simple information. And I produced the Nottingham obstacle detector. And the very corniest thing you'd ever hear me say is that a nod is as good as a wink to a blind man. The Nottingham obstacle detector, the nod, single channel, handheld, pulse echo. It did not give any texture information, and it only responded to the nearest object only. And I used the notes of the musical scale. I tried them going up as you got closer. I tried them going down. It didn't make a jot of difference. So I had them going down, because that's what the old sonic torch had gone down in pitch as you got closer. Now, notice the musical scale was so different from environmental sounds that it didn't really interfere with your ability to hear the traffic or the sound of your footsteps. A very simple device, which hardly took any training at all, and worked very well. But it had to be used in conjunction with a cane, because it, of course, the cane had to be looking after the curbs and the holes in the ground. The nod would find open doorways, it would find trees, find objects, and you could walk along with a bit of slightly clumsily, and it worked very well. I wanted to make the nod head-mounted. Use musical scale, nearest target only. Yes, here we are. And it required little training. The problem of making it head-mounted was, of course, I wanted to retain this nearest object only idea. And of course, if you're looking to the sides and looking straight ahead, and you've got a wall here, which is only a meter away, you're not going to get any information about what's straight ahead until it becomes nearer than a meter. Well, that's no good. That clearly wasn't going to work. And then I had a bit of inspiration. I realized that you didn't have to look simultaneously to the front, to the sides. You could use time division multiplex. You could look left, right, left, center, right. And of course, we can divide by 4 much more easily than divide by 3. So why not left, center, right, center, left, center, right. And when it looked left, it went to the left. It gave the musical note in the left ear. And I wired this up on a sort of breadboard thing, walked outside, and there was a lamppost there, and walked up to the lamp, fine, turned around, the lamppost flipped into this ear and walked past it. It was wonderful. It was great. It was superb. And then I walked up to a wall, and it was the it was the campanologist's nightmare. Now, the campanologist, of course, is the bell ringer, because this wall was simultaneously left, center, right. It was all over the place. Ding, 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 ding. And it clearly didn't work when he walked up to a wall. So I went back into the lab and I thought about this for a little while. And then I suddenly decided that I could fix it so that if you've got a center object, then you stop the time division multiplexing. You only concentrated on the center object until such time that you no longer had a center object, and then it would go back to the sides. And there was an unexpected bonus there, because whereas it had gone left, center, right, so as you're walking along a wall and there's only a wall there, it's ping, nothing, 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 ping, nothing, 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 ping. 1 in 4 would give you the distance to the wall. You came across a center object, suddenly you stop the time division multiplexing, and it's every time bang, you've hit it. You know, it not only was it in the center, but it was effectively at 4 times the repetition rate, because you were no longer doing the time division multiplexing, and it worked, and it was very nice, and I liked it, and I called it the Sonic Pathfinder. And that was the unexpected happy result that I didn't think of until I made it stop the multiplexing. Experimental results were pretty good. It was difficult when it got to a cluttered situation. There's no doubt about it. If you got into, if there were trees and overhanging bushes and things like that, it was hard. And I used to play a game. I used to play dominoes at the pub on a Thursday night with the lads, and I would walk home playing the game. What is the single item I need in order to take the next 2 footsteps safely? And suddenly it was this, and then it was that, and then it was something else. And I thought, what I need is a device that tells me these things. Nothing else tells me these things. And then the penny dropped. I realized that when the going got tough, when it got really cluttered, you know, a wet hedge, England, imagine England, the dripping trees and all the rest of it, a wet hedge and all the rest of it, I'd slowed down. Well, I could get the speed of walking from the flow of pattern of information coming into the device. And so I modified the device so it didn't have a range of 3 meters. It had a range of 2 seconds. It automatically adjusted its range. It chopped off the far range signals when you moved slowly. And that was a great boost to its success. It worked really well. It was very nice. It had several supporters, quite a number of blind people loved it. It was fairly easy to use. It didn't interfere too much. The earpieces didn't fit over the ears. They fitted near the ears, didn't prevent hearing of ambient sounds and taps of a cane and things. Of course, it had to be used in conjunction with a cane. And we made quite a number of them, and we evaluated it. And that's a picture of the setup I had, the Sonic Pathfinder. And my website is named sonicpathfinder.org. And one day I thought, hang on, I put it on the back of my car. I thought, this might help me reverse. And well, it did if you had perfect pitch, but I don't have perfect pitch. And clearly the display was wrong. So I changed the display for the car thing for a pulse repetition rate. Beep, 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 continuous if you got very close to the wall. And I called it reverse aid. And it's not just pulse echoes. You've got to discriminate against all the ultrasonics in the atmosphere. There's a lot of it around. So it's quite a cunning device. I was quite pleased with it. And it now has developed into the parking sensor, and chances are you've got it on your cars as well. But I patented it in 1983. What I did was I programmed the chip, because it's all based on a single chip, so that if you earth one pin, you get an aid for the blind. If you didn't earth the pin, you got the parking sensor. And my hope was that they'd be made in the millions for the car market, and the blind people would just squirrel off all they needed and just wire it up differently, and it would be a sonic pathfinder. It never really worked that way, unfortunately. I patented it in 1983. Now, you couldn't make this up. The patent agent was called Swindle and Pearson. The people at the university used to call them Swindle, Grab It and Run. And they were in Derby, and they did a reasonable job, but nobody wanted to drill holes in their car. I got involved with a local firm in Nottingham, and we put it on a number of delivery vans and a number of trucks, but it never got on into cars until about the year 2000, when it became original equipment, and by which time the patent had expired. So you're not looking at a multi-millionaire, unfortunately. I took it to Jaguar in Coventry, and all I wanted was a royalty. And they were very polite. They drove my car up and down, prototype on it, took me into the boardroom. They sat me down and they said, well, Dr. Hayes, it's very interesting, but we have to tell you, you like it because you're a one-eyed driver and you can't judge distances. Real people wouldn't want a thing like this. So there you go. There you go. That was a Sonic Pathfinder. In the 2017, I was sent a photograph by a friend of mine of a Chinese reversing device. Wouldn't be quite the same. It wouldn't tell you how close you were getting to something, but it would certainly tell you if you bumped into something. And this is the Chinese picture. In 1987, I came out to Australia, and I came to be the manager of research and development at the Guide Dog Centre in Chandler Highway. Now, at that time, they were very progressive. They wanted to embrace electronic devices and all sorts of aids for the blind, not simply the dogs. And I did lots of projects with lots of people, but one of the most interesting project was with the ANU, with Professor Adrian Horridge, an English guy who only died this year, and Srini. They were working on insect vision. They believed that they could make robot seeing systems based on the insect eye. And of course, the charge coupled device had been invented. And that's the insect eye. I mean, for goodness sakes, the heart of your digital camera these days is this multifaceted compound eye. We call them pixels, of course, these days. And using that and very simple algorithms, they were able to make devices for robots. And they nothing for the blind came out of the work there, but they did make some robot seeing systems, which actually are used in drones these days. When people fire send drones off to the Middle East to target somebody, they don't have to worry about its orientation with respect to yawing and all these terms, because this insect eye is looking at the horizon. It's looking wide angle at the horizon and keeps the whole thing orientated. And all they have to do is to point it at their target. And also, it was used on Mars on the helicopter. So that was one of that was spin-offs from that work. Since I retired, I worked at the Eye and Ear Hospital on the ethics committee for 7 years. They need a good atheist on the ethics committee from time to time. And I felt I was there a voice for the patients, because I'd seen that side of the business, whereas the ethics committee seemed to be hell-bent on sort of covering everything up that went wrong. And I've taught at the U3A. I've taught for 20 years at Manningham U3A, all sorts of subjects, like the science of the medicine, evidence-based medicine, history of that sort of thing. And these days I've homed in on cosmology. I teach cosmology. And then something happened. something happened last month, October. And the most remarkable thing, I received an email which had all the hallmarks of a scam. It told me that Richard Alsop had died and he wished to leave £2,500, English pounds, to any children of mine who were alive when he died. Well, I've got 4 kids, so that's £10,000. Well, that's about $18,000. And I didn't know who this fellow was. Well, I thought, come on. Well, I had a few days sleuthing this. I have a friend in York who's a lawyer. I mean, can you imagine a lawyer with a friend? It's hard to imagine. Anyway, I sent it off to my lawyer friend in York, and he said, yes, it looks very much like a scam. However, the firm who sent it from whence it came does exist. And he Googled Richard Alsop, and Richard Alsop had been the professor of transport engineering in London University. And that sort of rang bells because I'd done things with the Department of Transport. And so I wrote, I mean, the golden rule, of course, is when you get an email like that, you don't answer it. So I didn't answer the email. I wrote to the head of the practice. I looked them up and I wrote to the head of the chambers at the law firm. And it transpires that Richard Alsop had been a senior consultant to the Department of Transport. Now, I didn't hear back from the law firm, but I heard back the very next day from the man who'd succeeded Richard Alsop in this position, a man called Ben Haydecker, who was then the professor. And he said, oh, yes, Richard was very proud of the fact that during his period of involvement with the Department of Transport, the road toll in England had fallen considerably. Very proud of this, but he did realize that he wasn't the only person who had actually contributed that. And he wanted in his will to leave money to the families of people who'd made, and to use his words, a substantial contribution to road safety during his time. Well, I didn't know I had. You know, what's all this about? And my first thought, well, it's the reverse aid. I mean, the parking sensor. It must have saved the lives of lots of toddlers who ride their little bicycles behind daddy's car and things like that. Yes. But then I thought again, I thought, no, I did do things with the Department of Transport. And maybe it's some of these things. And I had served on a committee, the Joint Mobility Committee. It met in London. It was every 6 months. I took the train to London. And it was joint because it was the joint agencies for the blind, had representatives there, 3 or 4 blind people, a couple of academics, of which I was one, and about 3 people from the Department of Transport. And the way it went was that the blind people would ask for the world, and the Department of Transport people would say, oh, well, sorry, you can't do that. And I was sort of piggy in the middle because I had an interest in the blind and partially sighted, and I had a technical background. So occasionally I could come up with some sort of compromise. And there was one very memorable occasion in the 70s, way back, this is a long time ago, when the Department of Transport had decided to drop the curbs at pedestrian crossings so people in wheelchairs didn't have to do wheelies to get up the curb. Great idea. The blind people were incensed. No, we need the curbs. We need to feel them with our canes or hook our toes over the edge of the curb. We need to be able to detect the curbs. You can't do that. And the prospect of 2 major disabled groups in England fighting over the decision that the Department of Transport had made scared them to death. I mean, they were as white as a sheet. And I simply said, well, hang on. What we could do, we could develop a textured surface that we could put across the edge of the crossing. And if we're clever enough, we'll make it so it doesn't impede the wheelchairs, and yet it is sufficiently bold to be detectable by the feet of the blind person or the cane. And if you're going to do that, why not put a little strip across what in England we call the footpath? You call it the footpath, we call it the pavement, and the Americans call it the sidewalk, little strip leading to the crossing. And if you're going to do that, why don't you lead them to the center of the crossing if it's a zebra crossing, And if they have to push a button on a pole, lead them to the pole. So you either have a T shape or an L shape of textured surface. And they thought, well, this sounds good. This sounds okay. And they went away. And about 9 months later, I went along with lots of other people to the Road Research Laboratory at Crowthorne. Crowthorne is famous for being His Majesty's these days, His Majesty's Hospital for the Criminally Insane. It's Broadmoor. But it also is the Road Research Laboratory. I don't think they share the same building, but I mean, they're there. And I, with these other people, we walked on these surfaces, and unfortunately, we all decided on the surface that we liked. We all agreed. Amazing, agreed. And then 9 months later or so, I don't know what it was, my contact at the Department of Transport rang me up and said, we've put the first crossing in, and we've put it in outside the Palace of Westminster. Well, that's just round the corner from Big Ben. Big Ben is the bell in the Elizabeth Tower. Just round the corner at the side of the Houses of Parliament is Westminster, the Palace of Westminster. And they put it there. I said, well, I'm in London next week. I'll go and have a look at it. Well, what they had done, it was quite ridiculous. Not only had they put it across the edge of the crossing, they put it across the whole side of the footpath, the whole side. And there were these dolly birds in high heel shoes staggering across it. And there were ladies with pushchairs bouncing their kids across it. And I got back to Nottingham. I picked up the phone. I mean, I didn't know the level of the guys that I was dealing with. I mean, I'm sure that the guy I phoned was quite senior. I'm sure he didn't get too many phone calls like this. I said, you've blown it. You've absolutely blown it. It's totally unacceptable. All you need is a strip across the front and a line leading to it, and have a T-shaped if it's this crossing, and have a pole, have an L shape. He said, draw it on a piece of paper, fax it to me. It took all of 5 minutes. I faxed it off to him. Well, normally if the department get any information like that, they spend about 2 years evaluating it. Not this. That crossing was dug up next week and it became a T. And the T's are everywhere in England. And they're here in Australia. Choice of surface, textured surfaces, Palace of Westminster, and there is a T leading you to the middle of a zebra crossing. That's in Bendigo. I took that photograph last weekend. And that's an L. It's leading you to the pole, where you have to press the button, wait for the crossing, and then over you go. And the T's and L's are everywhere. And that was one of 3 possibilities. Maybe Richard Alsop knew about my involvement here. I don't know. And then there was another problem. Push buttons at crossings. In England, if you go to these crossings, you press the button and you join the green man phase when it's time to cross. You hear beep, 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 beep. Now you have the tick, 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 tick. You have the thing called the Ericsson rattle ticker. But there's a problem. If you go to Kew Junction in Camberwell, you've got 5 roads coming in together. There's a cacophony of these sounds, and you're a bit hard pressed to know which is yours. And because of that's the problem. In England, they would not have them at road crossings. Neither would they have them at what we call dual carriageways. You call them divided roads, where you have a crossing, sheep pen, and then another crossing. You might hear the other person's crossing, think it's yours. So they wouldn't have them. All those were silent. Blind people couldn't use them. So I sort of had an idea. I said, I come on a bit. Can I borrow a push button box? And I borrowed a push button box, and I stole or borrowed a Lego motor from my sons, my young sons. And I got a cap from a toothpaste tube, and I built this Lego motor into the push button box, wired it up as if it was a crossing. And during the green man phase, this thing spun round, and it was driven through a clutch. So if you were to grab it, it wouldn't wind you up like a Tom and Jerry cartoon, you know, it would slip. And I said to the Department of Transport, what do you think of this? A tactile display. And they said, great, but we can't have it made of plastic and Lego motors, and find somebody to make it in stainless steel. Me, you know. So anyway, I got the yellow pages out, and I found a firm near Nottingham. And again, You'd hardly believe it. An engineering firm called Rustington Engineering. Now, who would name an engineering firm with the word rust in it? Anyway, Rustington Engineering were thrilled at the idea. They thought, oh, an involvement with the university and the Department of Transport, what fun, you know. And they made about 6 prototypes. And the Department of Transport evaluated it, took quite a long time. And then they put them in everywhere. All the silent crossings had them in. And they paid Nottingham a royalty. And Nottingham shared that royalty with me and Rustington Engineering. So that was rather nice. And then for some reason, they decided they wouldn't just put them in the silent crossings, they put them in all the crossings. So if you go to England, I mean, most people don't even know they're there. I don't know whether you've got that. Yeah, the arrow is pointing at a little knurled knob sticking out the bottom of this box. So you press the button and you run your hands underneath, and then when it's time to cross, this thing starts to rotate. Well, that was another thing that I'd done, but I never rated these things very. This wasn't rocket science. I mean, I was very proud of the Sonic Pathfinder and the parking sensor, but this was a bit on the side, you know. And then 1981 was the International Year of Disability. And I got a phone call at Nottingham saying, look, we need an idea. We need an idea that links blindness and disability, disability and technology and science, something like that, something that will come up and have lunch with us in Bristol in 10 days' time and tell us your idea. No pressure, you know. So I said, okay, I'll try and think of something. Well, I'd been to San Francisco. And when I was in San Francisco, I was driven across that Golden Gate Bridge in an E-Type Jag of all things. I was in the passenger seat. And as we were going across, I said to the driver, hang on, you haven't paid. Everybody's queuing up to pay. He said, no, look at that gantry up there. And yes, it says something like 26.50. I said, well, what's that? He said, that's my bank balance. This is 1971. I said, how the hell did it do that? He said, well, I've got a transponder on the car. I go over the loop in the road, and by the time I've got a few meters down the road, it's interrogated my bank balance, and it's showing me what it is. And I was blown away by this. I thought it was incredible, fantastic. So I went to Bristol, and I said, I've had an idea. Oh, I was met at the station by about 3 people I knew and about 5 I didn't. And they took me off to lunch, sat me at the head of the table and said, well, Dr. Hayes, what have you come up with? And I said, how about a talking bus stop? Well, even I could see the body language. Oh, what is this about? You know? So I pushed my chair back and I stood up and I said, no, hang on. When I get home tonight, I walk to catch my bus. It's the gathering gloom. I can lean into the road and slow them down until I'm certain it's not mine and wave him on. Or I can peer at the bus and wait until I'm certain it is mine and leap out and stop him. Neither technique goes down well with the bus driver. We could have a loop buried in the road, 100 yards upstream, transponder on the bus stop could have speech synthesizer. They were coming into vogue in the 1980s. And it could say ding dong and number 6 approaching. And if you're going to do that, why not have a push button on the bus stop? So you press the button, it said the buses that use this bus stop are the number 6, next one due in 10 minutes, the number 54, next one due in 17 minutes. Well, they thought, well, this is quite a good idea. And they took it back to the minister. Well, what I didn't know was that the Sir Humphrey character, you've all seen Yes Minister, the Sir Humphrey character in the Department of Transport at that time was Sir Peter Baldwin. Now, Sir Peter Baldwin had worked at Bletchley Park on code breaking during the war with Alan Turing and those people. So he was very much into technology. He thought it's a great idea. Oh, we'll go for this. And they went for it. And the minister was a lady, Linda Chalker. She's now Baroness Chalker. And they decided to set it up at a little seaside town called Weston-super-Mare. Now, Weston-super-Mare was chosen because it's near Bristol, where the transport technical people are based. And there are a number of hotels that specialize in holidays for visually impaired people. And they had a bit of a celebration. They got it working bus stops, the buses. They had the press along, they had the Department of Transport people, blind people there. And I lived in Nottingham, right in the middle of the country, with 4 little kids. And a day at the seaside, I thought, I'll take the kids along. You see, so I arrived with the kids, and some people at the Department of Transport thought this was a bit naff. Anyway, Linda Chalker thought it was wonderful. My girls were 10 and 8, and she cut the cake and organized the girls to take plates of cake round to the blind people. So it was a celebration. It was a day out. It was lots of fun. Now, sadly, it never took off because it was a Tory government and they were privatizing the bus companies. And the new owners didn't want to spend money on this sort of thing. But talking signs of this ilk are here, there, and everywhere nowadays. But that was something that I got going. So that's really what it's all about. And I reckon that Richard Alsop, well, I know now, I found out since that Richard Alsop's reason for giving the money was related to these topics rather than the parking sensor. Well, I'm going to end now, and it's important to end on an intellectual note. Now, lots of dealings with blind people. I have a limerick told to me by blind people. On the breasts of a barmaid from Sale was tattooed the prices of ale, while on her behind, for the sake of the blind, was the same information in Braille. And to really end things, and no, you don't need to take gym shoes to a physics lesson. Thank you very much.